Today's topic is about failure mode effect analysis, and I'm going to show you one example of how to do FMEAs. A bit of background: FMEAs was initially introduced by the Department of Defense in the 1940s when they were working on safety critical projects. Eventually, the aerospace industry adopted this, and towards the 80s, the automotive industry started looking at the aerospace and then started using this for safety critical applications. It's only in like the 90s that the automotive industries kind of standardized this. Today, across all safety critical industries, nuclear, chemical, medical, aeronautical, robotics, this is a standard technique that people use to identify what can go wrong and what how can we mitigate it. So, what is an FMEA? An FMEA is essentially a design analysis technique which helps users answer four questions. What can go wrong in a system? What is the effect if something goes wrong? How can we mitigate it? And is the mitigation good enough? So, think once you've done your design and you want to start thinking about what can go wrong in the system, what can go wrong in all the sensors, or what can go wrong in like the mechanical components, what can go wrong in software. Then you want to think about what is the effect and how the user is going to perceive it. It doesn't really have to be the user, it could be how the effect another system perceives it as well. Now, depending on whether this is high risk or a low risk, we want to do something about it. We want to be able to mitigate it either by adding another mechanism that can detect or the or another mechanism that can prevent it. And then finally, we want to evaluate the risk. Now that we've developed these mitigation measures, is this good enough? I'm going to give an example of a very simple project that I worked on. So, a simple park is a system which is used in cars. Consists of three ultrasound sensors, rear left, rear center, rear right. This information is then going to a microcontroller. The microcontroller then detects if there is an obstacle around the vehicle, and then it informs the user through a display, through an audio warning. It's a very simple architecture. You can see sensors, microcontroller, and an architecture. Now, I'm going to show you a very simple FMEA here. Now, first things first, we need to identify what is the component for which we're going to perform the FMEA for. In this case, the component is the ultrasound sensor. Then we have to identify failure modes. In this case, we've identified two failure modes. Failure mode one is communication error between the sensor and the microcontroller because the sensor is communicating, and it could also be an internal communication failure. Just looking at row number one, then we want to identify what is the effect. So if you have a loss of communication, it means that you can no longer detect an obstacle, which could be a bit of a problem, which is why we rated the severity as 10 because a potential collision to an obstacle is possible. Then what is the cause of the error? The cause of the error is some kind of a communication interface between the microcontroller and the sensor that is lost. We say that the occurrence is very low if we have some design prevention measures. For example, in this case, electrical connectors are designed according to some state of the art standards. So we can say they're very durable, these connections will not be damaged throughout the life cycle of the project. Then we can also build some detection measures. For example, you can, in the microcontroller, build some mechanisms to see I send a signal to the sensor, am I receiving it back in a certain amount of time? If that is not happening, then there is something wrong. So that's a way to see, detect a lot of communication. Um, we say this detectability is 2, which means that we are able to detect almost all faults. So notice that the occurrence, detectability are rated very low, which means that they're very, very good measures that are in place. Once the occurrence, detectability, and severity are available, the RPN is calculated, which is a simple product of severity, occurrence, and detectability. 10 times 2 times 2, RPN gives 40, and based on the action priority table, the priority is low. Um, Here we see that the risk associated is very low, so we don't have to do anything else to improve the design. There might be other scenarios wherein the risk associated could be high, like in this case, wherein we have the occurrence is 10. And in this case, we'll have to do something to lower the risk. So you see it's already high risk. Uh, we can look at what can be lowered. Detectability is 2. It's unlikely it can be lowered any further. So we'll have to do something to lower the occurrence. And in this case, we try to come up with some new prevention measures to lower the risk. So this is FMEA in action.